All right. So this is lecture 23, March 3rd, 21. Okay. So we are going to continue a method of sections and by doing a few more examples. So let me just remind you, because this is the last lecture we have, in fact, on trusses. And you can watch the videos and you can watch that other uh, online course if you want, but this is it. Then we are going to move to a friction on Friday.
Professor Mar,
So, yes.
could you like focus the camera? It's not looking at your
Oh,
computer.
sorry. Here we
Thank
go.
you.
You're right. It's kind of fuzzy. Okay. I'm glad you noticed that. Okay. So remember the three main steps. Draw the XY coordinates, identify zero force members. Then the third step, which is the most important one after that, is what? You will start by looking at cutting the truss in such a way that you cut the member that you want to find its force and as few as possible other members. So the least number of other members. That's it. So let me, do a few problems here. I will. I have a few problems set up here for you. Let's say you have a truss that looks like this, and oops. All right, so you have a truss pinned here on a roller here. Let me label that A, B, C, D, E, F, G, H, I, J. So the truss is loaded here, 6 kilonewton, 6 kilonewton at this joint. And the problem is asking you to find member forces in IC, okay, and actually three member forces, IC, CJ, and CG, okay? So 1, 2, 3. These are the three member forces you want to find. So what is the procedure? Step 1, X, Y coordinate. Step 2, find zero force members. Do you see any zero force members? Anybody? Where do I start? Anyone?
Would corners B and D work?
That is correct, because you remember last time we said if you have two members coming to a joint and there is no external load at that joint, both of these would be zero force members. Same thing, joint D. Two members, no load at that joint. So these would go. Anything else? Any other members that you?
IH as well.
Yes, because at H you have three forces, two collinear. So this goes. And once that goes, joint I, three forces, two collinear, this one goes. So you see that the problem is reduced. And this is a very good example that shows you if you had not detected these zero force members, no matter what cross section, what section you perform, that includes, for instance, this member, you would have more than three unknowns. If you cut this one, 1, 2, 3, 4. If you got that way, 1, 2, 3, 4, 5. So no matter what section, you would have had more than 3 unknowns. Whereas now, if I want to find this member force first, and I perform a cut, that would be like this. I would only cut one other member. So you have only 2 members that I have cut here. Okay? So I would consider this section. In problems like this, you do encounter something interesting. I can obviously consider either free body diagram of this piece or this piece, right? But you look at it and you see that no matter which free body diagram I consider, in that free body diagram, I have also the support reaction forces that come into the picture. So I need to find those first, which is easy. You have AX, AY here, if I want to consider this one, AX, AY, okay, and RE. So I want to find these. You know, you want to make your life easier. If you look at a truss that has no forces acting along x-axis, it's obvious that then AX would be automatically 0. Even without writing this equation, you could have detected that, right? So it's only AY. To find AY, I take summation of moments about E is equal to 0, right? So that will give me negative AY, and I have not even given you these distances, and nobody asked anything. This is 1.5 meter, 1.5 meter, 1.5 meter, 1.5 meters, and okay, 2 meters and 2 meters. So AY, negative Y times this distance, 6. These two generate positive moment, plus 6 times 3, plus 6 times 1.5 equal to 0. If you solve for AY from here, you get AY comes out to be 4.5 kilonewton. Any questions? No? So let's move on. I want to find this. I performed this cut. So this would be the free body diagram now that I have, right? This is AY, okay? So this is the force of IC. These went away, right? So that's the only force. And this is the force of this member that I've got, which is AG, okay? And that's it, okay? This is 4.5 kilonewton. All right, I want to find this one. I don't need this one. I've not been asked to find that one, right? So what is the best course of action? First of all, resolve this into its component. The slope of this line here is what? 4. This is 3. So this is 4, 3, 5, right? So this is 4/5 FIC. This is 3/5 FIC. So by simply writing summation of forces along y equal to 0, this is the only unknown that comes into picture. So I have negative 4/5 FIC minus, okay, plus 4.5 equal to 0. That will give me FIC. That comes out to be 5.62 kilonewton. Force is coming towards the joint, so the corresponding member is in compression. Any questions? No? All right. So once I solve for that, now I've been asked to find these two. So again, what is the best section if I go here? I can cut it like this, but I have 1, 2, 3 unknowns, and I don't want that. How about if I cut it like this? I have only 1, 2 unknowns because I found this one already. So I would consider this cross section. That's better. So I would consider this free body diagram. This is f of IC, which is 5.62. This is that force that I want to find, f of CJ, and this one, force of CG, which I also want to find, okay? So looking at this free body diagram, again, resolving these into their components, okay? Both of these have the same slope, 3, 4, 5. So this is 3/5 of 5.62. This is 4/5 of 5.62. Get rid of that, get rid of that. This is 3/5 of FCJ. This is 4/5 of FCJ. Okay, so if I simply write summation of force of the line X is equal to 0, I have 3/5 of 5.62 minus 3/5 of FCJ is equal to 0. FCJ comes out to be 5.62 kilonewton. Force coming toward the joint, so the corresponding member is in compression, right? Now I can write summation of forces along Y is equal to 0. So I have negative FCG plus these two, plus 4/5 of 5.62 plus 5.62 is equal to 0. And I get F of CG, that comes out to be 9 kilonewton. Force is moving away from the joint, so this is in tension. Any questions? No question?
Just to clarify about your diagram, it looked like you had like symmetry kind of symbol or like equals on the 1, 2, and 3. Is that just marking which ones you're trying to solve for? Or is
Yes,
that-
in that order, yes.
Okay.
This one, and this one.
Okay.
That's what the problem was asking, in that order, yes. But you're right.
If there wasn't a 6 kilonewton force on point F, would you be able to use symmetry to solve for all of them?
Absolutely, very good point. Excellent point. If this wasn't there, right, force here and here would be the same. And of course, it happens because of the symmetry here that we have no other load, they came out to be the same anyway, but you didn't have to solve for that. You just would say, since we have symmetry, I don't need to solve for that, would be the same as this one. Okay, good question. So let's do another problem. I have another good problem here for you. I did this problem in the other section. So I made this up this morning. Okay. Yeah. All right. So you have a truss that looks like this. Okay. All right. We have a load here, 2 kilonewton. We have another load here, 10 kilonewton. So let me label this. It's pinned here, a roller here. Okay. Let me label that A, B, C, D, E, F. And these dimensions, 3 meters, 3 meters, 2 meters, and 6 meters. All right. In this problem is asking you to find, and this is an interesting problem because it's kind of sometimes I give problems like that on the exam that I ask you using only one, this is how the problem states. Using only one equation of equilibrium, okay, find force in member A, E, only. And I say, if you find any other forces along the way, you will not get any credit for the problem. Because I want you to solve for this unknown using only and only one equation of equilibrium. All right? So let's see what we do. Procedure is the same, right? Step 1, x, y coordinates, okay? Step 2, 0 force members. Do you see any 0 force members here?
Point C.
Point C. Here we have a joint with only 2 members, so no external load, so these 2 would go. Once those go, point D will also satisfies the same conditions or criteria. So 2 members, no external load. So these 2 both are 0 force members. But something more interesting now happens. What is that? Look at joint B. 3 forces, 2 collinear. So this one goes, right? So when that goes, it is as if instead of that load is acting there, it is like you have this load acting down here, because this load is carried by this member. So this is a force that this member carries and exerts at joint E. So the truss is reduced to a 3-member truss like this, and I want to find this member force. Any question? How do you do that? Well, procedure is the same. You cut this and minimum number of other members. I can cut it like this, obviously. I still have cut 2. But if I consider that cut, I have these 2 unknowns also. So I have 1, 2, 3, 4. Or even if I consider this piece of the truss, I still have 1, 2, 1, 2, 3. So I'm going to cut it like this instead. So I have only 2 unknowns if I consider this piece of the truss. So let me do that. But what I will do, I will do it this way. Okay. So you have this, you have this, and let me also, okay. So this is point E. Okay. I have this force, 10 kilonewton. I have this force that I want to find, F of AE, and this force, which is F of EF. I do not want to find that force. Okay. So how do I do that? I have 2 unknowns, and the section that I've considered has 2 unknowns, right? But I only want to find one of them by using one equation of equilibrium. How can I do that? Anybody? Let me show you. See, you want to get rid of this, right? What was this? I mean, this truss looked like originally. This is the problem you had, right? You had this. This was B, this was C, and this was D, right? All right. Can you see how you can find this unknown with only one equation of equilibrium? Anybody can guess? How about if I...
Summation of points around, or summation of
motion around D.
Around B, this is still is going to play, and
No,
this
D.
D, if I consider D, you can do that. Yes, that's a very good point. If I take summation of moments about point D, this would disappear. So I have this one. But there's another option, which is also a viable option, and it's easier in terms of the geometry. And that is if I continue this and that, in other words, if in this original truss, I had continued, found the point of intersection O, I can first of all find this distance by looking at the similarity of this triangle and this triangle, which gives me what? It's x over x plus 6 is equal to this, which is 2 over 6. So you get x comes out to be 3 meters. So I could have done that, but then I had to, when I resolve this, I needed to find this distance here, and it's not going to be as easy as that one. So let me resolve, first of all, this force into its components. And this one I don't have to resolve because it's going to go through that point, right? So what is the slope here? This is this, I mean, the slope here is given. This is 4 meters because this is 2, this is 6. This would be average of the two. This is trapezoid. So this would be just this plus that over 2. So this is 4, this is 4, this is 3. So this would be a 4, 3, 5 slope. Okay, so this would be 4/5 of FAE. This is 3/5 of FAE. Okay, so get rid of that. So now I take summation of moments about O is equal to 0. Okay, this passes through that. Oops, by the way, I have also this load, which I forgot to put. So this passes through that. I have the moment of these two, and these two. So let's just write those down. This one, this distance is 6. So I have negative 4/5 FAE times 6. This one also negative 3/5 FAE times this distance, which is 4. Okay. Then these two will generate positive plus 6 plus 10 times this distance 6 plus 2 times this distance 4 equal to 0.
Will you scoot
Yeah.
your paper up a little bit?
Oh, sorry.
Thank you.
Sorry. So you can see that this is the moment equation. These fourth moment of these two and moment of these two about 0.0. If you solve for the unknown here, FAE comes out to be 9.4 kilonewton. And the force is moving away from the joint, so that is tension. Any questions? So you can see that sometimes problems are easier than you can imagine. All right. So let's do another problem. I want to do yet another good problem. All right. So this is another example. All right. You have a truss that looks like this. Okay. 5, 5. Okay. And then here is 3. So you have a truss that looks like this. Let me complete the process drawing. All right. You have a support here. You have a support, which is a roller here. Let me label that A, B, C, D, E, F, G, H. And the loading truss is loaded like this at all these joints on the top. Okay, this is 2 kilonewton, 4 kilonewton, 4 kilonewton, 5 kilonewton, and then 3 kilonewton. All right, so the problem is asking you in this case to find the force in member HC, so this is the first one, and member HG, okay? Only those two, okay? So how do you start? All right. Again, if I first want to find this one, I cut it such that this member is cut and minimum number of other members. So I can cut it like this. I can cut it like this. I can cut it like this. No matter what other sections you consider, except for this one, you have to cut more than 3 members. So I will consider this cross section, okay? Or this section cut. But again, as the next, so the first step was XY, second section was 0 force members, right? I forgot to follow that. The reason I didn't, to be honest, I knew that there is no 0 force member in this truss, as you can see. Okay. So performing the cut, I can consider either this or this free body diagram. And again, you see that no matter which one, these reaction forces come into picture. So I need to find those as well. Needless to say that you have only 2 unknowns here because there is no force acting along the x direction. So AX would be 0, right? So I want to consider this free body diagram because it's easier to draw, geometrically less involved. So I'm going to consider this one. So if I want, let's do that. Let's draw that free body diagram first, okay? So you have this, okay? You have this, and you have this, and this. All right, so that's the cut that I perform. So what is the free body diagram here? I have this 2 kilonewton. This is A. This is B, 4 kilonewton. C has been cut here. This is H. Okay. And then I have A, Y. And let's assume this is F of B, C. I have not been asked to find that one. I don't need to. Okay. This is the F of HC that I want to find, and this is the F of HG. So these are the 2 that I want to find. Okay. All right. So first of all, I need this one. So in order to find that, I would, in this free body diagram, take summation of moments about E is equal to 0. So I have AY, negative AY times this distance. Did I give you those distances? No, 5 meters, 5 meters, 5 meters, 5 meters. And this is 3 meters and 3 meters, and this is 5 meters. All right. So AY times this distance, which is 20, okay, plus all of these forces, which generate a positive moment. Yeah, plus 2 times 20 plus 4 times 15 plus 5 plus 5 times 5 is equal to 0. That will give me AY. That comes out to be 8.25 kilonewton. So I have AY here. This is 8.25 kilonewton. And this is the free body diagram that I want to consider. All right. I only want to find, see how many unknowns I have? 1, 2, 3, right? So you can see that no matter what you do, by writing summation of forces along X and Y from this diagram, you cannot solve for these two, right? So what do you do? Any suggestions?
Professor, I had a quick question.
Sure.
Why did you skip the 4 kilonewton force that was 10 meters away when you were doing the summation of moments along E?
I have 2 plus 4 times 15. Oh, you know what? I just overlooked it. That's all. Sorry about that. So I have plus 4 times 10 also equal to 0. Good observation. Thank you. But this is the answer because I had solved the problem before. So what do you do here? That find only this force. See, you have 3 unknowns. You want to find only one of them. What do you do? Remember the general rule? If you have 3 unknowns, you want to find only one of them. What do you do? Take summation of moment about the point of intersection of these. So if I continue this line, and I continue this line, here I end up with a point O. Is it possible to locate point O? Sure, it is possible. Okay? Here in this diagram, this is that point O, right? How do I do that? Look at similarity of this. If this distance is X, look at the similarity of this triangle and this triangle, right? So you have X plus 5, which is this side. In other words, I'm looking at OBH and OCG, those two triangles that are similar. So this side, which is X plus 5 over X plus 10, which is this, is 3 over 5, right? So you get 5x plus 25 is equal to 3x plus 30. So x comes out to be 2.5 meters. So I have this distance. This is 2.5 meter. This is 3 meters. Okay? Now if I take summation of moments, about point O is equal to 0, only one unknown comes into picture, which is this one, right? Because this one and this one both pass through that point.
Wait, Professor Nori,
Yes?
how is the distance from A to B in the bottom picture 3 meters when you told us it was 5 meters above?
Oh, this is 5, this is 3, right? This
From
is
A to B.
3. This one, right?
No, that's B to H. From A to B.
A to B is 5 meters, right? Oh,
Yeah.
oh, sorry. This is 5 meters, sorry.
Oh,
Again, another mistake on my part. Thank you for catching it. That's right. So you want to find moment about point O. What do? You resolve this force into its components. But do you have the slope here you do. Look at this. What is the slope here? This is 5, and this is 3. So this would be 3, 5, square root of 34, right? So this is 3 over square root 34 f of hc. This is, okay, I'm sorry, this is 5 over square root 34. This is 3 over square root 34 f of hc. Okay, so take summation of moments about point O. You have this one, 5 over square root 34 times this distance, which is, okay, this distance, okay, which is 3, 5 f of h c times this distance for this one, and for this one, plus 3 over square root 34 fhc. This distance is 5 plus 2.5. Okay. Then what else do you have? These three forces. These two would be negative. You have negative 4 times 5 plus 2.5. This one, negative 2 times 2.5. And then this one, positive 8.25 times 2.5 equal to 0. That's your moment equation. And if you solve for that, you get FHC. That comes out to be 2.24 kilonewton positive force moving away from the joint. So this member is in tension. Okay. Any questions? Now that you have that, you want to find this unknown, right? So all I need is just to write summation of forces along y is equal to 0. I don't need this guy. I don't want to find that one, just these two. So I use that and resolve this into its component. Again, you have the slope here too. This is 2, this is 5. So you have 2, 5. This would be square root of 29. So you have this and this. This is going to be 2 over square root 29 FHG. And this is 5 over square root 29 FHG. I don't need that. All I need is summation of forces along y. So I have what? I have 3 over square root 34 times 2.24, which is this force. I have negative 2 over square root 29 FHG. Then I have negative 4, negative 2, plus 8.25 is equal to 0. That will give, if I solve for that, I get f of hg comes out to be a positive value of 9.15 kilonewton. Force is moving away from the joint, so this is also in tension. Okay.
Do you mind moving the paper up just a little bit?
Oh, sorry about that. You could not see it. Sorry about that.
Thank you.
Sure. Any questions? So we learned a few things today, but the concepts remain the same. For method of sections, follow those 3 steps. When it comes to cutting that member that you want to find its force, make sure you perform a cut that only cuts that member and as minimum number of other members as possible. No more than 3 for sure, because if it's 4, there's no way you can solve for anything. Okay,
On that note, so when you make the cut, do you want to make sure it like completely detaches, like completely cuts it in two?
exactly.
Okay.
Cut the truss into 2 separate pieces, yes.
Okay.
And then you consider the free body diagram of one of those pieces. Yes, good point. Any questions? Okay. I'm going to stop here because I only did these 3 problems in the other section. And we have covered a good number of problems. And this was the last lecture on trusses. We're going to start frictions on Friday, and we have only, believe it or not, yeah, we have what, how many? Yeah, we have on Monday, you have a quiz, and then you have 2 more lectures after that. So we have only 3 more lectures left. Any questions?
What is gonna be covered on the quiz on Monday?